So another example is H2O. Oxygen, we only have one oxygen in this formula multiplied by its mass, which is 16. Then hydrogen, we have two of them in our formula times its mass is 1. So it will be 16 plus 2. So the MR of H2O is 18. Number 10. Dry ice, or known as frozen carbon dioxide, which was once discovered by French chemist Charles Taylor. When dry ice is put in room temperature, it turns to gas. So it is from a solid to gas. So what is the process called? It's called sublimation, from solid directly to gas. Melting is from solid to liquid. Boiling is from liquid to gas, while freezing is from liquid to solid. So another question that they will ask that is related to this is which one gains energy or loses energy. So remember, when we have the heating curve, as we go up, it's gaining energy. So the processes that are involved in gaining energy are sublimation, it gains energy, melting, and boiling. While the cooling curve, it will show how different substances lose energy. So the different processes that requires losing energy or decreasing energy or releasing energy, is freezing and condensation, and also crystallization. Question 11. A student does a titration, and the following shows reading of the burette. Remember that when we are reading burette, we are reading it downwards because the one on the top of the burette is 0 and the one on the lowest are usually 50 cubic centimeter. So in here, we want to find out how much solution was transferred. So it means how much was removed from the burette. So we're going to find the initial reading. So 2 from above and 3 below. So we're going to read it going down. So it will be 2.7. While the final reading is 29 above and 30 below. So it is around 29.5. So to get the volume that was transferred, we just need to subtract 29.5, which is our final reading, to our initial reading, which is 2.7. Therefore, our answer is 26.8. So that is letter B. Remember, we're doing this because we started a burette at 2.7. If we started our burette with full or 0, it means we don't have to subtract it anymore. So what will be the reading? The final reading will be your actual reading that was transferred. So that is one thing that you have to remember when reading burette. Next, question number 12. The diagram below shows the apparatus used to separate the substance of mixture. So this apparatus shows a simple distillation. So we have different parts of simple distillation. First, we have here our round bottom flask. We want it to be a round bottom flask to make sure that we have even heating, because this part will heat evenly. We also have here our thermometer, which is used to measure the temperature of the liquid. or the substance, but in this case, we're using our thermometer to make sure that we know what substance is exiting our condenser. So as our liquid is boiling, it will measure the temperature of our vapor. So let's say, for example, we have a mixture that contains water. So when something is already exiting and we found out that it is exiting at 100 degrees Celsius, so we know that that is our water, because water boil at 100 degrees Celsius. Then the moment that the temperature starts changing, let's say more than 100, so we need to replace our container, because it means what will be exiting from that flask will not be water anymore, because it's not 100 degrees Celsius. Next part is the condenser. Condenser is what will help to condense our vapor back to liquid. So one part that is important in condenser is where we are going to put our water in and water out. So the position of water in and water out is very important, because it will help for efficient cooling. Then of course, the last one is our collecting container, which will collect the pure substance. The question is, what is the purpose of this separating method? Letter A, to separate crystal copper sulfate from a copper sulfate solution. So this is solution. So we can use this process to separate the solution. Letter B, to separate the sand from aqueous sodium chloride. So to separate the sand from aqueous sodium chloride, all we have to do is to do the filtration. Letter C, to separate the component of ink. For this one, we can actually use chromatography. Now we are left with two options, letter A or letter D. Both of them have solution. But the question is, what do we want to separate? Remember, what will be collected in the collecting container is a pure substance that will go out because of its fixed boiling point. Now in this case, letter D is looking to separate the water, while letter A is collecting the crystal copper to sulfate. So if we're going to use a simple distillation, letter D is our best answer, because letter A actually can be done using crystallization. So if we want to obtain the solute, a pure solute, crystallization is the best method. Now, this is called simple distillation, and to turn it into a fractional distillation, we just need to add a fractionating column. So a fractionating column could be made up of glass beads, or the one with the zigzag glasses inside. So fractionating column will give efficient condensing and evaporating to make sure that what will exit from our condenser is pure substance, because the fractionating column will help to continuously evaporate and condense our substance. Question 13. Copper has a melting point of 1085 degrees Celsius. When copper is mixed with tin, it will become bronze. So remember, bronze is another alloy. So it's a mixture of copper and tin. So this time, we will have a mixture which is not a pure substance. Which of the following is the predicted melting point of bronze? Remember, impurity, when you added something to a pure substance, it will become impure. Therefore, its boiling point and its melting point will be affected. One way to find out if a material is pure substance is by checking if it has a fixed boiling point or melting point. Once its melting point or boiling point changes based from compared to what it should be, so it means impurity is added. So if we're talking about melting point in impurity, it will cause it to decrease. On the other hand, the boiling point will increase due to impurity. So we're expecting that from 1085, the melting point will decrease. So that's why our answer is B. So it's not C because it's the same. And not D as well because this one increases. Now why not A? Because 0 is too far from 1085. It will decrease, but it will not decrease that far. So 918 is the predicted melting point of bronze. Question number 14. A mixture of colorless amino acid is separated using chromatography. The solvent used is ethanol. Now remember the formula for ethanol, which is C2H5O6OH, C2H5OH. A chromatogram is sprayed with ninhydrin. So why do we need to spray something in our chromatogram? Because our amino acid is colorless. Therefore, after the chromatography or our chromatogram, we cannot see anything from the result. So we need to spray a ninhydrin. So what is ninhydrin then? This is our locating agent. So which row describe the purpose of ethanol and ninhydrin? Okay, so ethanol, the purpose of it is to separate the amino acid, because as we have mentioned, that's the solvent we use. So it means we want to separate our amino acid from the mixture. What's the purpose of our ninhydrin? As we have mentioned, that is our locating agent. So it's why letter D. So if you're asked what is the definition of locating agent, it is a material that we sprayed on the chromatogram to make our result visible, especially if we are using colorless amino acid. Question 15. Which of the following is the least reactive in group 1 alkali metals? So what are the elements in alkali metal? Starting from the first one, which is lithium, followed by sodium, potassium, rubidium, cesium, and francium. So in one of our discussion, we showed that when we add these alkali metals in water, it will produce the reaction. And the more reaction it is, it means it is our most reactive element. Actually, it's the cesium and the francium that are the most reactive. They are the one that will create explosives, so they will react vigorously, while the lithium is our least reactive. So which is the least reactive? Based on our choices, that will be sodium.